Okay. Let me first share my screen. Okay. So, good day to all who will be watching this video, most especially to our professor, Miss IB Humarang. So, this video presentation is our um, Electrical Circuits 1 Laboratory Activity 2 in Voltage, Current, and Resistance. Okay. I forgot to share my screen. So, this is the screen one. Okay. So, this is about the voltage, current, and resistance. So, by the way, my name is Mered Lucero, and this is a group project, a group presentation, but unfortunately, my partner, Gregorio Masakupan, is cannot be available right now, but some of our um, some of the topics here are already tackled by us earlier, but uh, apparently, sadly, due to some important matters, he cannot be available right now for the um, recording of our presentation. Okay, um, so anyways, let's just continue doing this this activity. So we have here the instruction and guidelines to about this activity. And these activities objectives are explore the characteristic of a resistor that are variable in this model, and then identify how each characteristic affects the resistance and current flow. Explain your ideas about why the characteristics change the resistance and current flow and voltage of batteries. Use understanding to make predictions about a circuit with light and batteries, and cite examples of importance of studying resistance in the engineering profession. So let us go with the part one of this activity. So we have here the link. So let's just copy this. Copy. Then paste it here. Okay. So some of this are already done. So anyway, let's just try to do this step by step. Okay. So when we follow the link, the link will lead us into this interface. This is about the pet.colorado edu, and the topic is about the resistance. So we have here the interfaces have this formula. R is equal to P L over A. So this P L and A stands for the R stands for the resistance. The P is the resistivity. So this is regards the material to be used on the conductor. The L will be the length, and the A will be the area. So let us do this number one instruction. So open resistance in a wire simulator link given above. So uh, just like what we have done, then explore to develop your own ideas about how different factors affects its resistance and also ability to allow current to flow. So your simulator must look like the image below. So basically we are right on our first steps. So the number two, so describe several of your experiments and your observation with captured images. So from the simulation. So answer the given questions below. So first is the letter A. If you change the cross-sectional area of the resistor, how does the resistance changes? So we have here the steps uh, or the experiments we have done. So let's just do this. So we are with the cross-sectional area. So this cross-sectional area is the diameter of the conductor that we will be having. Okay, so we can see here as since we are focusing on the area, we will be not not uh, not do anything into this the resistivity and length, only the area. So we have here first, if the value is cannot be we will not do anything on the given. So as a initial, we have here the resistivity of 0.5 ohm centimeter. The length will be in 10.00 centimeter and the area is 7.5 centimeter squared. So we have here, paste it here. So this will be the initial or the original. Then we will be trying to get the value as we increase into the maximum possible area that this experiment have. So the diameter, the maximum diameter will be in 15.00 centimeter square, and the resistance will be 0.333 ohms. So we have it here. The big area will be the 0.333 ohms. Then lastly, we will be doing the minimum or the least possible value of the area that these experiments will be having. So the possible least area will be in 0.01 centimeter squared. So the resistance value will be in 500 ohms. Okay, so basically we just scrap this and paste it in our document or the word that we will be passing to the we will be passing. So we have already pasted here. So the three, the initial, the big area, and the small area. So we will be so by explanation we come up with these observations. Okay, so observation. So we have, I said we have already done this earlier. So based on the data given by the experiment, where the initial data of the cross-sectional area is 7.5 centimeters squared. So this is the initial. The value of the resistance that is in 0.667 ohms. So we have here this. Then as we set the cross-sectional area of the resistor with the maximum possible value of 15 centimeters squared, the resistance value becomes 0.33 ohms here. Then lastly, when we set the area into its lowest possible value in the experiment, which is 0.01 centimeters squared here, the resistance becomes 500 ohms. So guide regarding to this, we can identify that this clearly shows that the resistance value changes as we change the value of the cross-sectional area of the resistor. So judging from the resistance as it acts when we configure the value of the cross-sectional area, it shows that the resistance acts inversely with the diameter or cross-sectional area of the resistor. So what does that mean? So that simply means that as the cross-sectional area increases, the resistance decreases. While when we decrease the cross-sectional area value, the resistance increases. So simply in Tagalog, kapag tinataasan daw natin tong diameter ng area o ng diameter ng wire conductor or tinataasan natin yung area niya, yung resistance naman niya ay mas bumababa. Okay? Then on the opposite side or inversely the opposite of it, habang nililiitin natin ng wire or binabawasan natin yung diameter niya or yung area niya, mas tumataas naman yung resistance value. So that is the inverse relationship of the resistance with regards to the area of the cross-sectional. Okay, so next we will be having the current through a circuit, the current through a circuit change. So answer, explains, and evidence. So we will be actually medyo nalilito kami dito, but guiding to this having the change the cross-sectional area and how does the current through a circuit change. So ang kinalilituhan lang naman namin, so the one we are confused about into this is we don't have the circuit. So anyways, as we understand, or we will be assuming that this is the relationship of the resistance value to the current. So, so guide our experiment letter A and serve as a guide in answering into this. And I thought this will be same as the earlier, but we will be adding this paragraph to simply explain what the effects of the current, effects of this resistance to the current in the circuit. So this will be the data. Then we will be having this, we will be using this Ohm's law as the relationship of the current with regards to the resistance. So we all knew that the Ohm's law is B is equal to I and R, and having this, what they call this one, having this, other relationship. So just by transforming this initial equation of B is equal to I, we can have the formula for the I, or the current, and the R for the resistance. So although maybe I will be stating this, so although the question was not really clear above, since there are no available circuit in the simulation, our idea is we will be using the Ohm's law for this. So since the question is about the current and we are assuming that it's being related to resistance, the formula that best describe this is through deriving the Ohm's law as if we are looking for the current value. Okay, so the formula of in current is equal to the quotient of the voltage when divided to resistance. So current is equal to B, or B divided by R. So that the answer will be, the quotient will be the current. So the relationship of current with regards to resistance is inversely proportional. So which is, if the resistance value increases, the current decreases. So habang tumataas yung resistance natin, bumababa naman yung ating decreases. So that's the inverse relationship means. So inversely, habang tumataas naman yung ating resistance value, habang bumababa ang ating resistance value, tumataas naman ang ating current. So that is why as the cross-sectional area of the resistor increases, so habang tumataas yung natin, diameter or cross-sectional value, resistance naman natin ay bumababa. And if the cross-sectional area decreases, the resistance increases. So that is the inverse relationship of the cross-sectional area with regards to the resistance and current. Okay, so let us go with the second, or the B. If you change the length of the resistor, how does it affects the resistance changes? So we will be going back to the simulation. So this time we will be having changed the length of the resistor. Okay, so this we will be just reset this one. Okay, so as we reset this, we will be having this again, this initial set value 0.5 in the resistivity, 10 in the length, and 7.5 centimeters squared to the area. So basically we just input it here. So this will name as initial. Then we will be having configure the length. So we will be having the, okay, so you can see here that this changes. So as we configure the length into its maximum possible value, which is the 20.00 centimeters squared, the effect in the resistance will be 1.33 ohms. So this is also stated here on our first paragraph, which is basically this is the data that we get. So this is the in statement. As we set the length with the maximum possible value of 20 cm, the resistance value becomes 1.33 ohms. So this is this one, the longer length. Then the shorter length is what this one is 7.5 sorry, the 0.1 centimeter, and the effects will be 0.007 ohms. So let us see if this is same with this. Okay, 0.1 centimeter and 0.007 ohms. So basically these are the effects or the screenshots of what we are having on the actual simulation. So here is the actual or here is the our main observation to that. So judging from the value of the resistance as it acts when we configure the value of the resistors, the value of the resistors in terms of length is resistors length. So we will just edit this. It shows that the resistance act directly proportional with the length of the resistors. So as the length of the resistor increases, the resistance value also increases. So just like here, when we change it to 20 from initial of 0.667, it increases to 1.33. Then when we decreases this from 10 to 0.1, the value is in 0.007 ohm. So just by that, we can clearly say that the resistance act directly proportional to the length of the resistor. So as the length of the resistor increases, the resistance value of the increases, while when we decrease the length of the resistor value, the resistor value, the resistance also decreases. So basically, that's the main observation and explanation to that. Okay, so the other one is the current through a circuit change. So this also aligned with this length. So the length with regards to the resistance and to the current. So this is the first activity. This is mainly the A. So we just simply write this resistance value changes, so current value also changes. So we will be also using this I is equal to BR since we are relating the current to the resistance, because resistance also acts directly with the length. So based on the given data, this is the observation, the main parameters, the parameters that we get when we done this first experiment. Then this is the main observation that we have. Okay, so although the question was not really clear above, since there are no available circuit in the simulation, our idea is we will be using the Ohm's law for this. So since the question is about the current, and we are assuming that it is being related to the resistance, the formula that best describes this is through deriving the Ohm's law as if we are looking for the current value. Okay, so the formula is equal to the quotient of the voltage when we divide it to the resistance. So the relationship of current with regards to resistance is inversely proportional. Okay, so which is the resistance value increases and the current decreases, while if the resistance value decreases, the flow of the current increases. So this is also same with, that is why as the length of the resistor increases, the value of the resistance also increases. Okay, so ang ano natin, relationship po ng ating length to the resistance is directly proportional. So dahil po siya ay habang tumataas yung habang humahaba yung length niya, tumataas din yung ating resistance. Then habang bumababa yung length or mas umiikli siya, bumababa rin yung kanyang resistance. Okay. So this is basically our observation with the relationship of the current to the resistance and the current to the length or the resistance to the length. Okay, so lastly, the letter C. So what do you think is this formula's usefulness to engineering material? So we have here the first formula, the resistance is equal to the PL over A. So this is equal to the resistance is equal to the resistivity multiplied to the length divided by to the area of that conductor. Okay, or that material. So this is related to the Ohm's law, which is this one. B is equal to I times R, and can be transformed to this set of other formulas, which are in getting the current and the resistance value. Then we also input here the materials resistivity table. So this is already given to us by our professor, IB Humarang. So this is generally, and so the followed what to call that, constant. So you can say this a constant in the resistivity value of this set of materials. So we have here the silver, for example, 1.645 times 10 raised to the 8 power. Then the copper, the gold, aluminum. So this basically the most common use material in conductors. So okay, so let us back to this. So usefulness to engineering materials. So well, the formula is really effective in engineering materials because it has a direct effect or direct relationship with the resistance. So this is here what we are talking about. So yung resistivity natin is have a direct effect or direct relationship to the resistance. So it is showed by the formula in the P and the resistivity. Each material may have different resistivity value. This is it. This is given by here. Resistivity value, which we can say have different resistance. Okay. So each material may different resistance value. So generally speaking, selection of materials should be considered first in engineering because it has a direct or indirect effect on the value of their voltage and resistance. Okay. So this basically our observation to that. Then let us go with the second part of this activity 2 and circuits 1. So let us copy this one. So this is a different simulation. So we are already done to this. Okay. So this will lead us into this. Okay, so makopy na natin siya. Then this is another set of instructions. So open circuit construction kit, link given above, or click the lab tab, then explore to the develop lab tab. So let's click the lab tab. So this may be this one. Okay, so basically they are in same interface. Yes. Then build two circuits below in which the left resistor is 10 ohms and the right one is the 30 ohms. Take note the voltage battery resistance of the bulb. Use real valve for the circuit and click the icon on the bottom right of the advanced section. Your simulator might look like this. So we just have to copy this one. So let us try to copy this one. So nasa left natin is 10 ohms, then the right one will be the 30 ohms. Then 100 parehas yung kanilang voltage or battery. So we have here also what you call this one? A switch. Then both lamp. So copy natin siya. Ganun lang naman siya. Kuha na ako nito sa actually. Okay, meron tayo dito battery. Then meron tayong light bulb here. Alin-alin lang natin ito. Hindi lang to. Then switch. Okay. Then lagyan natin ng values. Para kitang-kita. Yan. Okay. So connect natin siya using wire. Alin natin para maganda. Okay. Then additional wires. Joke. Yan, kompleto na siya. Kompleto yung circuit niya. Ay, sorry, naka-close. Ayan, open yung circuit natin. So, this one will be in 10 ohms. Then, meron siya tayong 100 volts. Medyo ano na to Okay na natin. Sabi naman ay 100 volts muna. So, mapapansin natin dito, kapag click natin tong arrow, ang kanyang increment ay 0.1. So, kapag konti na lang, point yun ang ating gamitin. Then, other one daw ay 30 ohms. So, another set. The right one, we will be having a 30 ohms. Okay, battery. Then switch. Okay. So connection. Okay. Then another wire. Complete the circuit. Okay. Okay. Kompleto na. So same na siya. Click natin daw. Okay, kompleto. Tapos change natin tong value nito into 100 volts. Kasi ganun din yung nasa may ano eh. Okay, 100 volts. Then, ang value nito ay 30 ohms. Sabi sa experiment yan. 30 ohms, parehas, 10 yung kanilang light bulb. Okay. So, basically, ito na yung last niya. Mukha lang siyang konti, pero tingin ko madami ito eh. Okay, so, use your understanding of voltage, resistance, and current to answer this question. So, what do you think will happen when the switches are turned close? So, why do you think this happen? Close natin. Okay? So, syempre, dahil na-complete yung circuit, so, as we turn close, sorry, as we switch on or close the circuit, the light bulbs will turn on. Okay, so yun ang ating ilalagay. Kailangan natin ng screenshot with here. Yes, screenshot. So, close na siya dyan. So, yun ang ilagay natin dito. Medyo easy lang natin para di naman nakakahiya. Okay. So, basically, this is the image. So, ilagay natin dito yung una natin gawa. Ilagay natin. Yeah. So, maglagay tayo ng space. Then, siguro dito natin ilagay yung ating observation. Paragraph siguro natin gawin natin tong single. Okay naman. Para mas maganda na yun. Okay na to. Then, lagay natin siguro yung kapag turn off pa siya. Kasi ginawa natin yung circuit eh. So, open muna natin siya. Para pakita natin na ginawa natin. Yan. So, open natin siya. Hindi ko na nilagay po yung dito po, yung mga ibang set ng parameter. Pero napakita naman na ginawa natin siya sa actual na video. So, lagyan na natin siguro ng note. Natin na actual, siguro lagyan natin na actual circuit done. Actual circuit done. Anday natin. Ay. Then, alisin natin yung ating para maganda naman siyang tingnan. Ito. Ulit, andito pala. Okay. Save. Then, kakopyahin lang natin to. And yun nga, explanation natin. Ang tanong kasi, what do you think will happen when the switches are turned off? Why do you think this happens? So, as we close the circuit, valves turned on. Turned on. Okay. So, This happened because the circuit was complete or closed. Diba? Ganun naman siya. So, or close. The input, sorry. The source, the power source, the power source, ang tawag natin doon, reach the output, or the load yung term nila kasi dito. Sa amin kasi, sa trabaho, outputs normally tawag namin dyan eh. Power source reach the output or the load. That is why causing it to function. Yun na lang siguro. So, medyo clear naman siguro yan. Explanation na yan. Okay. So, next, the letter B. How do you think the light's brightness will compare in these two circuits? So, why do you think that happens? So, observe natin daw yung brightness. So, kitang-kita naman. So, yung brightness, maybe the brightness here will be the, we can say that the layer. So, the layer is the thickness. So, sa drawings kasi, yung thickness ng lines will be named as layer. So we can see here. So maybe this in terms of maybe this one is look as 1, then this one will be 1.5, and we can also see that this is much more longer than this one. So we can conclude that the circuit one here with the 10 ohms, this is because we are looking here in the resistors. So the circuit here with 10 ohms is much more brighter than this circuit having a 30 ohms. So, lagyan natin yon. So, screenshot na rin natin siya siguro. Ay, meron na tayo niyan. So, ito na rin yan. So, gawin na natin to para maayos tingnan. Okay. We have it here. So, same na siya. Center lang natin. Then, lagay natin ang ating explanation. So, lagay natin yung explanation natin. How do you think the light brightness will compare to this? Based on the experiment, is on the actual simulation, the circuit having the 10 ohm resistor is much more brighter. Hindi na pala brighter na lang. Brighter than the circuit having the 30 ohm resistors. Okay. So, why do you think that happened? So, syempre, dahil mas maano yung yung resistors niya, or mas maliit yung persang pumipigil sa kanya, kaya mas malakas yung ilaw na pinoproduce niya. So, yun ang ating i-explain. So, this is because that the resistance value in circuit 1 is lesser than the circuit 2, which causing minimal resistance to the circuit. O, tama naman, di ba? Resistance to the circuit ito causing it to function, causing its bulb na lang, its bulb to brighten up more, up much better, and to circuit 2. Okay, yan, okay. Circuit 1 and circuit 2, lagyan pala natin ng name para hindi tayo malito, or hindi malito yung makikinig sa atin, no? Hindi malito si ma'am. Ano na yan? Parang mali tayo dito. So, ito si circuit 1, ito naman si circuit 2. Circuit 1. Ito naman si circuit 2. Circuit 2. Okay, so ito naman, next. Konti na lang, guys. Choose one circuit to observe and leave the switch closed. Open the switch of the other circuit. Try to increase the wire resistivity. Can be found on the right side. Describe what happens. So, tanggalin natin yung isa. So, siguro mag-focus tayo dito sa unang circuit. Then, increase down natin tong wire resistivity. So, advance siguro. Ito, wire resistivity. Press natin siya. Ano nangyayari? Uy, bumabagal siya. Ayan, no? So, dito, medyo mabilis siya. Then, pagdating dito, mabagal na siya. So, ilagay natin yung mismong observation na natin kasi sabi mag-provide ng example. Ito lang important na part eh. Yan ang ilagay natin dito sa ano natin. Pero meron na tayong observation. So, ito na yung unang setting natin. Openin lang natin to. Lagyan natin ng arrow. So, ito pala yung pangalawa. Ito yung una. Okay. So, uy, kung magka-crash. Okay. Kala ko magka-crash na. May problema kasi minsan tong ano ko eh. Nangyari. Minsan may problema po tong PC ko. Katandaan na rin siguro kasi gamit ko rin to sa work eh. Buti nga meron tayong option na gamitin siya. Lagyan natin to. Ito yung initial. Then, place it here. Nagkapalit na sila ng pwesto. Siguro, i-lessen na natin yung length niya. Then, provide tayo ng space. Lagay natin to, arrow. Para makita ni ma'am na nagpalit tayo ng setting. Para maganda din siya tingnan. Okay? So, basically, yan na siya. Ito yung ating then, nalagay na lang tayo ng natin, observation. Na nakita na nga natin kanina. Okay, so English siya. So, as we increase observation, as we increase the wire resistivity, lang naman kailangan, hindi naman siguro much more detailed. Okay? Describe what happens lang naman. So, as we increase the wire resistivity, the flow of the current is decreasing. The flow of the current decrease. Okay, so flow of the current decrease. So clearly, decrease, causing the current yan eh. So, parang by explanation, yung as we increase yung resistivity, bumababa yung current natin. So, parang ano siya, inversely proportional. So, bali, clearly shows that, ilagay natin yan, clearly shows that current, wire resistivity is inversely proportional to current, causing also, causing the brightness. Yan, para makaka-affect. Syempre, pag mas mababa yung current, mas mababa yung ilaw ng ating ilaw. Ay, ilaw ng ating bulb or load. Causing the brightness of the light to change accordingly. Yun na lang siguro. And next, continue na lang guys. So, try to increase the voltage. Click the battery and adjust the voltage bar to the right. Okay. So, ang i-configure naman daw natin is yung ating battery resistance. Sorry. Ang sabi ay increase yung voltage. So, initially, yun na siya. Okay. So, hindi na natin ginagalaw to. Then, kopyahin muna natin yung initial na screenshot natin. Here. Lagyan natin siya dito. So, parang yun na rin siya. And then, lagay natin na kinonfigure natin tong into 400 volts. Kung naman ma-reach yung 400 volts. Hindi siya yung ano eh. Medyo tayong try to increase the voltage to 400. Click the battery and adjust the voltage bar to the right. I'm sorry, but I think there might be some problems here. Maybe this one. Okay, mali pala tayo nang lagay dito ng battery. So this battery is maybe much more powered siya. So open muna natin yung circuit natin. Then try to use this one. Pero wala naman siyang ganun ka difference na kanina. So pasensya niyo na lang ma'am siguro kung ganun yung naging itsura. Pero hindi ko na po siguro babaguhin, sayang po yung oras natin. So eto na lang po. Natin siya. So ito pa lang isa ay mas mataas ang kanyang voltage compared to this one na ang limit is 120 volts. So this one, the limit will be in we can yan, mas mataas yung niya configuration. Or yung parameters na pwede mong iset sa kanya. So, try lang down natin na gawin siyang 400 volts. Hindi ko na po babaguhin ma'am yung pagpasensya niyo na po. So, basically, parehas lang din naman sila. Kaya, tama yung natin kanina. Tawag dito, tama naman kasi same lang sila ng parameters dito kanina. Yung 100 volts ang gamit ko. Kaya, same lang sila ng reaction dito sa 10 ohms sa 30 ohms. Kumbaga, hindi siya magbabari as long as ang ating ino-observe naman ay yung yung resistors lang. Pero this one, ino-observe naman natin yung reaction ng siguro ng current dun sa voltage pag mas mataas. So dito lang naman tayo nakapokus to, kaya ayun na lang po yung ating anahin. Okay, so initially siya, ito, palitan natin to into this one. So initial, ito siya. na natin siya. Then paste it here. Copy natin yung... Okay, so ito siya. Then lagay natin yung kanyang reaction. Kapag sorry. So initially daw, tingnan, meron talaga dito ng 100 to 400 volts. Lagay muna natin siyang 100. Yan, ito muna palang 100. Close na natin yung circuit para makita. Ay, hindi pala siya. Yan, nagbabago pala. So ito ang itsura niya pag 100 volts. So same pa rin naman siya sa kanina kasi same lang yung niya, yung value. Ito niya pag 100 volts. Then try natin siya increase into 400 volts. Yun, nakikita natin na medyo sunog min. Sunog. Yun ang kanyang grabe, nagulat ako dun. Yung pala mangyayari sa kanya. Okay, so basically ganito ang kanyang reaction. At 10 ohms, same parameters dun sa ating unang mga experiment. Ang nagbago lang is yung voltage. So ginawa natin siyang mas malakas yung supply niya. So 400 volts or yung energy source niya 400 volts. And ang reaction niya at 10 ohms resistor is masusunod niya yung resistor at masusunod niya rin tong mismong supply. So ganun. Ibig sabihin hindi kaya ng resistor yung ganun kalaking voltage. So basically ang mangyayari is sunog yung circuit or sira yung circuit, tapos nakasira pa tayo ng nakasunog pa tayo ng ating, kumbaga kung sa bahay to, sunog ang bahay or sunog ang ating pera, parang ganun. So as we try to increase the voltage, click the battery, adjust the voltage bar. What happens? So as we increase the battery source, initial of, nilagay natin from initial value of to value of 100 voltage with to 400 voltage with the resistance value, nilagay natin is with the resistor value of 10 ohms. Circuit will break, will crash na lang, hindi crash, will be damaged. This mainly because that the battery source voltage is too much for the resistor to carry. Yan. Kasi yung mga resistors meron din yung values na allotted sa kanya. So para magkumpleto to, tatasan lang natin siguro yung resistance. Ganun naman pagka yun sa actual na. Kasi ako minsan na-try ko na rin kasi ito kasi minsan nagagawa kami ng sa trabaho. Kaya medyo ko na siya. So, okay to kapag tinasan natin tong resistance. Gawin natin actual. Saan natin resistance yan? Yan o, di ba? Pinasa natin resistance, nagka-okay siya. Di ba meron tayong pinag-aralan ng mga ilaw? Ay, mga ilaw, mga dito, yung color coding. So, syempre, different resistance, may action yun dyan. Baka mamaya kasama para sa gagawin. Hindi naman. So, yun lang yung natin. So, napatunayan natin na tama nga yung ganun. Yung reaction ng yung kumbaga, pinipair talaga yung yung resistor mo depende sa voltage mong, the voltage source that you will be having. So what are the apparent current flow in the load light? There is no need for screenshots. Just discuss it among your group mates. So wala si paring Greg ngayon. Pero kanina kasi napag-usapan na namin 'to eh. Hindi lang namin na-transfer dito sa sa Word. Pero ayan, na-discuss na namin 'yan. So ang syempre, nakita naman natin the factors, the factors that affects the current flow in the load is R. Siyempre, ilalagay natin. So, una, R. Siyempre, dapat complete yung circuit. R. The complete circuit. Siyempre. So, ano ba yung complete circuit natin? Meron tayong source. Meron tayong resistor at right resistor for the load, and syempre yung valve, the load, and syempre some load, and syempre kung meron kang additional na na switches, so yan yung magpapaano dyan. Basta complete yung circuit. ETC, lagyan natin siguro ng ETC kasi syempre kailangan ng wires. Ano pa ba? Meron pa yung iba dyan, dinadamihan ng mga resistors. Yung iba, maraming sets ng circuit, ng switches. So, yun yung mga kumbaga. I'm saying that because kasi di ba sa mga, yung iba kasi sa factory automation, we can have this set of inputs para makontrol yung ating yung reaction ng ating loads or reaction ng ating output. So, kami, kasi minsan nagtatry ako mag-program. So, usually, I tried using relays and PLCs. And yun, in providing complete circuit, we tend to create diagrams to that. And siyempre, dahil nga kinokontrol mo yung for safety purposes, we have this input devices or the safety devices. So we can classify that as inputs. So yun yung mga sensors para ma-ensure natin yung safety ng ating mga ng ating process, or ma-provides yung tamang step-by-step procedure ng ating ng ating ginagawang diagram, or para ma-function yung ating output. So yun yung anyways, that is just for sharing. So there's no need for you to just discuss. So ano pa ba? So dapat complete yung circuit natin. Right? So emphasize lang natin dito siguro. Right? And correct. Ayun na, right? Pair of, so resistor syempre. Right pair of resistor. Sama natin yung load to source. So dapat tama 'yan. Bukod sa complete, tama dapat yung pagkakaparehas nila, kasi mangyayari nga pag hindi siya tama, masusunog. Okay? So tama yung complete yung circuit, tama yung mga selection mo, and then also yung nilagay natin kanina, wire resistivity, and yung isa, ano bang tawag dito? Yun na rin pala yan, and wire resistivity. Ito na yan, tamang selection. Right selection. Lagyan natin. Right selection. and fairness. Yan siguro. Fairness pa tawag doon. Yun, maintindihan. And wire resistivity. Nalagay natin. And wire resistivity. Yan. Yan yung mga nakaka-affect ng ng ating, kasi dito lang naman tayo sa circuit na to eh. Yan yung mga nakita natin. So, some importance of studying resistance and spec engineering profession. There's no need for screenshot. Okay. So, na lang. Last. So, ako personally, but ito, the importance of studying this resistance is really sorry, reconstruct natin. Studying resistance is really essential in engineering because it is such an it is provides resistance is really essential in engineering because it provides direct control, like direct control over our voltages and current. Yun naman yung niya yung relationship niya di ba? Magkakasama yung resistance, current and voltage. So lagi magkakasama yung tatlong yan. Mababago-bago lang yung relationship nila. Depende sa kung ano nang hinahanap mo. Pero yun yung kanilang kumbaga, yun yung talaga magkakasama. So provides direct control over our voltages and current. It protects, we can say that it protects our circuit into dito. Its proper selection. Its proper selection protects our circuit into dito. So it protects our circuit and to provide to circuit to function according to our plans, according to our dito idea and plan. And yan isa yan eh. Then also yun I think sabi siya knowledge siya. Importante siya eh. Resistance eh. So a great knowledge for great knowledge to understand how our electronic devices functions. As we use it. Yan. Use it in our daily lives. Yan. Ito. Furnace. Selection and dito. Right selection and dito. Combination. Yan. Combination. So basically, ito na yun. Save na natin siya. Okay. So double check natin. Nasa downloads. Ang ating itsura. pangit nun. Okay. So basically, this is the yan. And okay. So basically, this is our group presentation in Electrical Circuits 1 Laboratory Activity 2. So this is the one that we'll be passing on our LMS. So after then we'll just the incomplete here will be the link for the group. So basically I will be posting it here after I get the path, so to where we will be saving this one. And ayun, thank you for staying and watching this video until the end. We're really sorry that my partner Gregory Masakupan were not here in doing this video presentation, but I assure you that we are having a great collaboration, and uh, that we are ensuring a participation for each. And just what like I had said earlier, we are previously and earlier, we have already discussed this, and basically we already tried this one, even though we are not fully get all the answers to this, but we ensure you that we already discussed this one. And yan, thank you po ma'am for watching until the end, and maraming salamat po. Sana po may matulong po kami sa paliwanag namin ng tama yung aming aralin, at naintindihan din po sana namin. So maraming salamat po. Bye bye. Okay. Eh hindi naka-record.